Hello everyone, hope you guys are doing well. On this video I'll be talking about the introduction to organic chemistry, the video material that you guys asked for. So, about the learning objective, in this case we're going to talk about the differences between the organic and inorganic compounds. And then we're going to talk about the unique characteristics of carbon atom in terms of covalent bonding, identify hydrocarbons, identify functional groups, distinguish between empirical molecular formulas, distinguish between structural formulas, and construct 3D models of organic molecules, which we have actually done in the class, but I'm going to show you how to write them. So, what is carbon? Carbon, we said that in the class, we need to look where we have carbon. We have carbons in all plants, in all living organisms. We have it in DNA. In every human being, we have carbon abundance. We have them in organic products, also in petroleum products, as you can see over here. So, all living and most non-living organisms, they do contain carbon. Okay, so now let's look at the electronic configuration of the carbon. It is 1s2, 2s2, 2p2. So as you can see, on the first shell we have 2 electrons. On the last shell we have 4. That means that carbon can make 4 bonds. Okay, so I'm drawing a carbon with the 4 electrons around it. That means that carbon can make 4 bonds. Okay, so we need to always have 4 bonds. That means that it has a valency of 4. Okay, so the next slide we talk about the differences. Back in the day, people were dividing chemistry into organic and to inorganic ones. Organic compounds, they're the ones that are coming from the living organisms, but the inorganic ones are coming from the non-living organisms. But now we have a lot of differences. So it was back in the day, but now it is different. But we have a specific definition for organic chemistry. It is the study of synthesis, structure, reactivity, and the properties of diverse group of chemical compounds primarily constructed of carbon. So I said that it's mainly about carbon. Okay, but we have some exceptions. Such as these guys. I'm gonna write you down their formulas for carbon. So we have carbon monoxide. Carbon monoxide, which is the toxic gas. It's you can't see it with your eyes, but it's a gas that can kill. And CO2 is the gas that comes out while we breathe out the air. And then we have carbonates such as sodium carbonate. Okay, and then potassium carbonate. These are carbonates. Okay, and then I will give you example for hydrocarbonates, which is sodium hydrocarbonate, and then potassium hydrocarbonate. And then for carbides we have sodium carbonate, and then cyanides. We're gonna give you 2 cyanides, sodium cyanide in here, or potassium cyanide. These are the elements that have carbon in them, but they are inorganic ones. Okay, if you remember, we have it in our quiz. So these guys are the inorganic compounds that contain carbon in them. Okay, perfect. So now we move on. We're gonna be talking a little bit about how people were thinking back in the day and then what stuff has changed. So in 1828, a German scientist, Wohler, synthesized organic compound for inorganic. We talked that back in the day they were saying that this is non-living organisms where you get the inorganic compound, and organic compound is the living organisms, such as like you can only get organic compound from living organism, right? But this guy from a non-living organism, he synthesized and made an organic compound. There was a first discovery where he showed that you can get a organic compound from non-living one, but you just need to run a couple of steps in here. Okay. So now we have a introduction. We're going to be talking about hydrocarbons. What is hydrocarbon? It is made of hydrogen and carbon. Okay. So as you can see here, we have ethane. We're going to talk about their names. We have in here carbon and hydrogen. That's why this guy is a hydrocarbon. Okay. But the one that we have in here, it is ethanol. And this is not a hydrocarbon. It is alcohol, which we will talk about later on. And then ethanol have oxygen in it. That's why it is not a hydrocarbon. Okay. So now we know what is hydrocarbon, what is not. So this is another one. We have in here propane. These black ones are carbon atoms, and the white ones are hydrogen. Okay, so I told you we have constructed these models in the class. I told you guys about this one, about carbon having 4 valency. As you can see, I have 1 bond here, 1 bond here, 1 bond here, 1 bond. So 1, 2, 3, 4 bonds. And look at this carbon, 1, 1, 1, 1, 4 bonds again. So this guy is called propane. And the formula of the propane, we're going to talk about this, but it is C3H8. If you count the number of hydrogens, we have 8 of them. But look at the ethanol, the one just we had in here. You see this? So we got 2 carbons here, and then I got hydrogens. And there's actually another hydrogen behind the back. It's not visible. We have another hydrogen, and then we have oxygen here. This is ethanol. So it shows that it is not a hydrocarbon, but this guy on the left is hydrocarbon. But there is also one thing. Organic compounds, they can have hydrogen. They have carbon mainly, right? We have talked about it. The second element we have is hydrogen, and we can have oxygen, which we have in ethanol. So ethanol is organic, but it is not a hydrocarbon. Propane is organic too, but it is a hydrocarbon. Okay. But we have other chemical compounds which they have nitrogen, sulfur in it, and we call them organic compounds. Okay. We can have organic compounds which have nitrogen and sulfur. They're not hydrocarbons for sure, but we can have them. So don't think that organic compounds only have hydrogen, carbon, and oxygen. They can have nitrogen, sulfur, but they come out in a small amount. You have like 10 carbons and just 1 sulfur or 1 nitrogen, just like that. Okay, we can even have a fluorine and iodine there too. Okay, so now hydrocarbons. We're going to show you another example, but in this case, you see, we have a double bond, which we have done in the class with the models. But look at the hydrocarbon, because it's only made of hydrogen and carbon. We're going to look at the number of bonds. You see, I have 1, 2 bond, and then 3 and 4. So carbon in here has 4 bonds, same as in this guy. I have in here 1, 2, again 3 and 4. So carbon 4 valency of carbon is met. Okay, so this is organic compound as well. And then now we're gonna divide organic compounds into 2. Organic compounds, they divide into 2 categories mainly. One is aliphatic and the other one is aromatic. Okay, These are also the type of hydrocarbons, but generally you can say that organic chemical compound, they fall into two categories. One is aliphatic and aromatic. Aromatic ones gotta have six carbon in a ring, okay, and they need to have a double bond, three double bonds, and if they have this structure, six carbons with the three double bonds, this is called aromatic. And the reason it's called aromatic, it's because it has a smell. Now, aliphatic, the name stands for fat, but it's not. It doesn't mean that it is fatty or something like that. It's just aliphatic ones. They are not in. So this guy, aromatics are ring shaped, and this aliphatic ones are in chain. For example, if I have carbon connected to another carbon and then carbon on like this, so I'm going to fill out with hydrogens because I need to fill them up. And this is aliphatic. It's not in ring. It is a chain, okay? But when you have a ring with three double bonds, then you have aromatic, which we have in this case. So look at the aromatic ones. They have structure, 6 carbon atoms, 1, 2, 3, 4, 5, 6, with a double bond, contains double bond. You see I have 1, 2, and 3 double bonds here. Now this guy is also aromatic because I have 1, 2, 3, 4, 5, 6 carbons with 1, 2, 3 double bonds, but in this case I have another functional group attached to it, but it still is aromatic. Okay, they're all aromatics, and this guy is aromatic too. I have here 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. So they are all both aromatic. I mean, all three are aromatic in this case. Now we're gonna compare the aliphatic hydrocarbons. Aliphatic hydrocarbons, we have couple types of them. We have alkanes, and alkynes. We have actually done this with you in the class. So alkanes have only single bonds. Alkenes have one double bond. Alkynes have a triple bond. For example, this guy is ethane, which we will also learn as we go. This is ethene. You see the ending. I have ethene, ethane, alkane ending here, alkene. And then look at this one. This one is ethyne as the ending in here. And it has a triple bond. Okay, so I have here a single bonds only on alkane, and I have a double bond in alkene, and then I have a triple bond in alkyne. Now we're gonna go into example. And questions. We're gonna look at some of the examples. As you can see here, I have only carbons and hydrogens. That's why I have hydrocarbon, and because I have a double bond, it is called alkene. Okay, the functional group of one double bond. You see this one here, it made it alkene. And we look on the one on the right, you can see that I have here iodine, which is why it's not hydrocarbon, although I have a lot of carbons and hydrogens here. This guy is a hydrocarbon because I only have hydrogen and carbon, and because everywhere I have a single bond, it is called alkane. But this guy in here is alkyne because it has a triple bond, and it is hydrocarbon because I only have carbon and hydrogen in here. Now we're gonna go, this is a bit of a lot of information for you at this stage, but we're going to introduce you to different functional groups. So I told you that if I have only single bonds, as in this case, you see here, and carbon and hydrogen, it's called alkane. If I only have carbon and hydrogen, but a double bond there, it is called alkene. If I have a triple bond, it is called alkyne. Now that six ring carbons with the 3 double bonds, it is called aromatic. And the functional group, the name of it is phenyl, but it is aromatic compound. Okay, aromatic. Now this guys, if they're, this one's in here, if they're in a chain fashion, they are, for example, CH3 here, and then CH2 here, CH2 here, CH2, CH2, and CH3. They are aliphatic, okay, but this one's in here is aromatic. The only other one we're probably gonna discuss are gonna be alcohol. I said if I have a OH group attached to it, it is alcohol. Do you remember we discussed ethanol? Ethanol there. It is the same functional group. Ethanol was C2H5OH. This is how it looked like, the open form. Okay. This is functional because of this OH. It is a alcohol functional group, and the name ending finished with ethanol. And we have here aldehydes, which we will discuss in the other videos, and then we have the ketones. So aldehyde has an ending with the carbon, double bond, oxygen, and hydrogen. This is aldehyde. And then ketone has a carbon with the double bond, but there is no hydrogens on both sides. Okay, this is ketone. The other ones, don't worry about them, we won't be covering them at all. So this guy in here, this is just given for information, but this is the shape of carboxylic acid. Okay, you will discuss this next semester. Now, these are the names of couple compounds. Don't worry too much about them because we haven't covered the nomenclature. I want to draw you some of the alkanes in here. For example, we have an alkane, right? Let's draw the shape of, for example, propane. And then I got here, propane is C3H8, and then I got 3 carbons, CH3, CH2, CH3. Okay, and then if I open there all of the hydrogens, it will be like this. And as you can see, it is all single bonds. Okay, single bond, and that's why this is alkane functional group. Okay, alkane, get the ending alkane, and the name is propane, just like so. Okay, now final remarks and conclusion. Hydrocarbons are organic compounds exclusively containing carbon and hydrogen. Aliphatic and aromatic hydrocarbons are 2 types of hydrocarbons based on their structure. Aliphatic hydrocarbons are bonded in chains or rings. Aromatic hydrocarbon is based on benzene group. So now I remember, I just forgot to tell you guys, aliphatic ones, they are in chain form, but they're also in a ring form. But there's difference between the aromatic ones. Aromatic, I said that it is in a ring of 6 carbons, but I need to have a double bonds, 3 double bonds. Okay, this is aromatic. So aliphatic ones come in chain and ring form. So I'm going to show you the chain form is, for example, propane, CH3, CH2, and CH3. But the ring form is going to be, for example, 6 carbons like this, but they don't have a double bond. It's all single bonds, okay? So this guy is aliphatic as well. But when you have a 3 double bonds, then it becomes aromatic. So I want you to see the difference. Now we're gonna look into this slide. So hydrocarbons, they divide into two: open chain, closed chain. Okay. Now you have open chain and closed chain, where you have in open chain you have saturated and unsaturated ones. Saturated ones means it only has single bonds, single bond. So do you remember I showed you propane? But when you have a double bond or triple bond, it becomes unsaturated. As you can see here, we have how many hydrogens here? 8 hydrogens here, but I have here 6 hydrogens. And then here I have 4 hydrogens. So as we lost hydrogen on this ones, we went from 8 to 6 and 4. They're all have less hydrogens compared to the saturated ones. So saturation means that are full of hydrogen. So these guys, they are missing hydrogens to complete their single bonds. I want you to guys pay attention. You see, this one is here, Cn, and then hydrogen is 2n plus 2, meaning that carbon number is n, hydrogen number is 2n plus 2. But for alkene, it is CnH is equal to 2n. So it has 2 hydrogens less than alkane, and then alkynes have CnH2n minus 2, which means it has 2 less hydrogens than alkene and 4 less than alkane. So overall, as you decrease the number of hydrogens and you make double and triple bonds, you become unsaturated. So now we're gonna look at the closed chain ones. So these guys overall, they're all open chain, they're all aliphatic. Okay. But now in here we have a closed chain. The one on the left is aliphatic, and the one on the right is aromatic. Okay. So look at the formula of cycloalkanes. It is CnH2n. Although it is same as alkene, but we have no double bonds. So alkene and cycloalkene, they have the same formula. But the reason cycloalkene has 2 hydrogens less than alkane is because it has a ring shape. When you have a ring, you lose 2 of the hydrogens. For example, I'm going to show you. I have CH2, 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 CH2 here, 6 of them. As you can see here, I have 6 carbons and hydrogen is 12. The reason I lost 2 hydrogens compared to alkane, you see I have Cn2n plus 2, 8 for H, is because of the ring. But I do not have no double bonds. You see, everything is a single bond in cycloalkane. That's why it is saturated. But aromatic ones, they have 6 carbons like this. Now I'm gonna throw it in here. So carbon, CH2. Actually, it's not CH2. It is C, and then C. I have a double bond, 3 double bonds. So I told you carbon can have 4 bonds, so the rest I'm gonna fill with hydrogens. And then this is aromatic one. It has a carbon in a ring shape and it has unsaturation because it has a double bonds, 3 double bonds with the 6 carbons. Okay, so we covered this part as well. Now we're gonna go into homolog series. So homolog series is a series of compounds that have the same functional group, and each member differs by the just CH2 unit. So I'm gonna draw you this guy's in here. For example, this guy is methane. We're gonna learn about it. So this guy is methane. So we have here 1 carbon and 4 hydrogens. Okay, add 1 CH2, meaning add 1 carbon and 2 hydrogen, it becomes 2 carbons and 6 hydrogens, which is C2H6. Now look at this guy. I have here C, and then I go add 1 CH2 group here. This guy. 1 CH2 group to methane. You see this? So I split this guy from here, and in between I added 1 CH2 group. Now it transformed from methane, CH4, to ethane. Okay, now what if I add 1 more CH2 group to it? Look at this. It will be so I'm adding it. Now it will be propane. So propane, the formula is C3H8. Okay, this is C2H6 and this is CH4. So we went from methane to ethane to propane by only adding CH2 groups. And these guys, because they only differ by CH2 group, they are called from the same homolog series. Okay, so these guys are all alkanes because you see the end methane, ethane, propane, the ending alkane. They have their number of carbon number of N, and H is 2N plus 2. Just check the numbers, you will see that it matches the same formula. So 2 carbons, 2 times 2 plus 2, it gives you C2H6. Okay, they only have single bonds as you see here. But you can have homolog series within alkenes and alkynes. For example, I can have ethene, and then I can have propene, and I can have butene. They are all homolog series. And then same thing could be ethyne from alkyne, ethyne, and then propyne. They are all same homolog series because their difference is CH2 group. Okay, so now I have the list of the alkanes. So methane, ethane, propane. If you remember, we already discussed this over a song, and then heptane, octane, nonane, and decane. So the formula is CnH2n plus 2. So check out the first of all the carbon number. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's pick the 5. It is carbon 5, and then if you look at the formula, 2 times 5, it is 10 plus 2 is 12. So look at here, pentane is C5H12, and it is pentane. Okay, now because the only difference between them is CH2, they are all homolog series, the same homolog series. Okay, so representing alkanes. Now we use structural formulas to represent hydrocarbons. You will notice that each carbon atom forms a single covalent bond to 4 other atoms. This is alkane. I want you guys to really pay attention here. So I said that carbon has a valency of 4, right? So meaning that it needs to have 4 bonds. But because alkane only forms single bonds, I will have 4 single bonds. Okay, you see I have 4 single bonds. And then look at the ethane. I have 1, 2, 3, 4, 5, 6, 7 single bonds. Okay, they are all single bonds. But if you look around carbon, it is 4, and then look around this carbon, it is 4. Okay, so now structural feature of compounds, carbon compounds. They can be open chain and cyclic. We talked about it. It's either chain like this, for example, like chain like this, or they can be cyclic. They can be straight or branched. We were going to talk about the straight and branched ones, meaning that they can be like just like this, or they can have a branch, okay, like a tree. They can have a branch. This is a branch, and this is another branch. And then they can be saturated, unsaturated. We talked about it. It's a double bond, triple bond. It gives you unsaturated. But if you have only single bonds, you will be saturated. Okay? Rings can be carbocyclic or heterocyclic. Now about this one. So rings can be only made from carbon, okay? Or they can be made from carbon and, for example, oxygen, okay? So in this case, when you have only carbons, only carbons, it is carbocyclic. But when you have carbon and some other elements such as oxygen, it is called heterocyclic. Okay, so for this one, I'm gonna show you how to write molecular formula, expanded molecular formula. So molecular formula is like this. For example, CH4, it is methane. C2H6 is ethane, okay? And so on. But expanded formula is when you need to draw everything. For example, carbon, we said that for methane is CH4, right? So we will have 4 hydrogen bonds. This is expanded form. And then I can have, so don't worry about this one, this is actually condensed form, condensed version. So now let's look at the ethane, and then I have 2 carbons and I have hydrogen. You see, I expanded everything. I have only single bonds, and the one in here I have methane, and this one is ethane. Okay? More ways to represent. So we have couple ways. One is skeleton, one is expanded, one is condensed, one is line, and then the other one they forgot to put in here, it is molecular. So molecular, I already show you guys how it is. Skeleton, I'm gonna show you expanded with dead. So for example, let's do this guy, ethane. In a so molecular formula of ethane, it is C2H4. Okay, expanded form is like this. This is expanded, but the skeleton form is only carbons are written. So carbon and carbon. This is the skeleton formula. Okay, now there is one element. There is one compound shown in here. We have carbon, 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 and carbon. This is the skeleton formula. Let's write the expanded form of this. Expanded is going to be like this. So I said that carbon needs to have 4 valency, right? So look at this carbon 1, for example. We have only 1 bond. So it means that I need to have 3 more bonds, because I do not draw hydrogen in skeleton. Now in expanded form I do. Let's draw the expanded version. So the expanded version is going to be like this. I'm going to draw each hydrogen. You see, I'm going to complete with 3 hydrogens, because I need to have 4 bonds. Now look at this guy. For example, carbon 2 here. Now this guy also has a 1 bond down, so I need to fill it with hydrogens. So I will fill it with as much as hydrogen so I can have 4 bonds. But in this one, look at this carbon 3. I have here 1, 2, 3 bonds. So I need to put one more hydrogen to make it 4 bonds. And then look at this carbon 4. I have one hydrogen, and then one hydrogen. So because I had one bond, I filled it with 3 hydrogens. So this is my expanded form. The one I drew, this is expanded. And the one on the left is skeleton. Okay. Now, if you want to write the molecular formula, molecular, all you need to do is to write down carbon and hydrogen amount. So let's check this guy. How many carbons do I have? So I have 1, 2, 3, 4 carbons. So it'll be C4. And then let's check out the number of hydrogens. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so hydrogen is 10. But I want you to do a quick calculation. Look at here. Because I only have single bonds on this guy. I know that it is alkane, right? I can get the molecular formula of this just by knowing the carbon number. Carbon is 4, right? And I said that alkane is CnH2n plus 2, right? So if I'll do the calculation, it will give me C4H10, just like I found in here. Okay, so we know that this guy is alkane because it has the same formula. It has same formula, and because it has only single bonds. Like, you guys can see that everything is connected in this organic chemistry. So we did this expanded form with you guys. This is expanded structural formula. Now the condensed formula. Expanded to condensed is super simple. So you see this guy, carbons. So we have carbons in here, right? So I got carbon, and then carbon, and then another carbon. So how many hydrogens do I have? 1, 2, 3 in here. So I put CH3, and then I have here 1 on this carbon, so I'll put CH. And then I have 1, 2, 3 carbons on this guy, so it'll be CH3. And then I have 1, 2, 3 carbons on this, hydrogens in this guy, it'll be CH3. Now this is my condensed form. Okay, so condensed formula is super easy. Now the line structure. A lot of you guys are struggling with transitioning from the condensed to the line diagram. So the condensed form was like this, right? So this is my condensed form. In a line diagram, I do not draw no carbon, no hydrogen. So no carbon, no hydrogen. Now look at it here. Carbon, and then we have a carbon like this. So each end of the line, each end and each corner is carbon. Okay, so I have here 1, 2, 3 carbons, right? I draw it like this. 1, 2, 3 carbon. And then in here I have 1 carbon, and I just make it just like so. Okay, so the shape is like this. Or if I want it, I can draw it like this. Or if I want it, I can draw it like this. It doesn't matter. These are all the same thing. You can turn it around, it will be the same thing. Is that clear? So I'm just gonna draw the shape all over again. So molecular one is C4H10. Okay, now the expanded form is like this. Carbon. I have here hydrogen, and then I got here hydrogen, and then here hydrogen, and the hydrogen. This is my expanded. Now condensed one is this CH3, and then I got CH3, and then CH3 here, and then the line form is like this. So each end of the line means carbon. So just like this. Okay, so these are the names of the classification of organic compounds. They have shown the expanded form in here. So methane is one carbon, ethane is two carbons. They are like this, propane and butane. And the alkane. Alkanes form a new homolog series. Their members only differ by CH2, meaning that they are all homolog series, like, right? Homolog series. So they have a single bond. And alkane formula is like this: CnH2n. Alkenes are unsaturated because they have a double bond. They are named using the prefix and end ene. Okay, so look at this guy. I have you see, I have here four carbons, and then I have here one double bond. It means that this is alkene. Okay, alkene. And then if you count the number of carbons in here, I got 1, 2, 3, 4. It'll be carbon 4. And according to formula, it is got to be CnH2n. So I need to have 8 hydrogens, right? Let's count it. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so because of one double bond, I lost 2 hydrogens. Okay, so same thing in here. So they're all the same, A, B, C, D. They have one double bond, but they are isomers, and we're going to talk about the isomers in the 3rd chapter of organic chemistry. Okay, that's it, guys. I hope this helps. I'm going to make more videos on the worksheets.